Chapter 1, Section 1, Evaluating Algebraic Expressions, Translating to Algebraic Expressions, and Translating to Equations. A lot of language. Really, one way to look at algebra is it's a language in itself, and we're going to set up some definition or learning the words and the language of this so we can translate from English to algebra and then be able to use the properties of algebra to solve problems. And when we get into equations, we'll have that ability to do that. So let's get through some of this terminology. Evaluating an algebraic expression is first they're going to define some words like variable. We usually use letters of the alphabet for this, and like they say, the letter N is a variable. It's really a position holder or a box or a slot where we could have a varying number or a varying value that could go in there, thus the word variable. A number like 60 is called a constant. 60 represents 60 units of something. It's a constant thing. We're going to say that it doesn't change to 62 or 63. If it started doing those kinds of things, then we'd be talking about a variable. And then we're going to talk about operation signs like multiplication is an operation, addition is an operation, division, subtraction, and so on. And then a variable expression is has a variable, sometimes a constant, and some kind of operation that makes an expression. So an algebraic expression consists of variables and or numbers or constants, often with operation signs or grouping symbols. For example, the algebraic expressions are like these examples, and they show a lot of examples in math and algebra books, and which is and this is very true. They say like a picture's worth 1,000 words, an example's worth like 1,000 pictures. This really illustrates a lot of that, and especially when you get multiple examples, you're going like, oh, okay, I get what they're talking about. But it's also important to get what they're talking about here, okay? By actually reading this. The key is to get these words and these definitions down for what they're talking about. There's a couple reasons I really like to emphasize that. One is that if you're going on from this course, you're going to go on to other algebra courses, math, sciences, and all those kinds of things. It's going to be real important so you learn how to use the material that's presented to you. So you need to know the definitions of those terms. And also, it's not a lot of fun reading a math book, but it is very focused, and there's very little on a page of a math book that isn't important, or it wouldn't be there. So pay attention to the details, and especially the whys, and we're going to talk about how we're going to use these different things eventually to be problem solvers. So we're going to talk about strategy. So the next word that's blacker here, right, or it's bold, is evaluate. To evaluate an algebraic expression, we substitute. This is another key word, is we're going to substitute a number in for the variable and find out what that expression will be as far as a numeric value. And this result is called a value of the expression, and the table below lists several values for the expression 60 times n. And also, here's another way to write that, is just 60n. When there's nothing between a number and a variable or two variables, it means there's multiplication happening here. This dot they use, mostly they get rid of that x for multiplication because we use x as one of our variables so much. Okay. So in this case, they have this table. They say, well, if we have cost of tickets are $60, and we wanted to know how much we would collect if we sold a certain number of tickets, they put a variable for that because that's going to vary, right? Depending on how well the sales go and so on, well, this number will change. Well, to get the collected value in dollars, you take 60 times the number of tickets that you sold, or 60 times n. So if they evaluate that, this expression in this case where n is 150, we'd end up with $9,000. Again, to put the words to this, we are evaluating the expression by substituting 150 in for n, which gives us a value of $9,000. And then they give us some examples to evaluate each expression for the given values. Now make sure you read the entire thing here. We have a simple expression x plus y. So whatever values that are substituted in for x will then be added to whatever values we add in for y. Well, then they say, well, here's a value for x and here's a value for y. So to evaluate this expression, we'd put those numbers in for each one, do the addition in this case, and we get 65. For b here, it's 5ab. That means 5 times a times b. And they tell us a is equal to 2 and b is equal to 3. So we take 5 times 2 times 3, and we'd end up with 30. This next example is the area of a triangle with a base length b and the height length of h is given by this formula. So the area of a triangle A, this capital A, equals 1/2 times the base times the height. And to find the area of, then they ask us to find the area when they give us values to substitute in for those variables, and then we evaluate. Now this looks like an equation, and it truly is an equation, because we're kind of just working on the right hand side of this equal sign. But what we could, at the end of this thing, I could say A area is equal to 25.6 square meters. Now notice too, here's another important point. They have labels on these distances. B is 8 meters, M for meters, and height is 6.4 meters. Notice when they substitute in, they brought in those label names for meter, right? And we end up with, we can change the order of a multiplication with the commutative property, which we haven't covered yet, but we can change that order to say this is 1/2 times 8, which is 4, times 6.4, which is 25.6. But it's also meters times meters, which we haven't got through the exponent stuff. But this is meters to the 2 power, or the short, or the nickname for that exponent of 2 is called being squared. So this is meters squared, or square meters, okay? And area comes in squares. So this unit, and basically using the unit value, we'll come out with a label that makes sense for what they're asking for. When I'm asking for area, I need squared meters, or meters squared, right? And so this is, you know, each example that goes through the book, usually it isn't just like, here's another one. They usually kind of bring in some new information. So it's very good to go through all the examples. This part could be easily missed about what do I do with that meter label. Well, this next part is translating to algebraic expressions, which is really, now it's like a English to algebra dictionary is what we're going to look at. And they're going to talk about how phrases translate and those kind of things. So we can take basically word problems or real problems in the world, translate them into an algebraic expression, and then later a algebraic equations, and solve those. This is a very good handy page to have available when you're working on any kind of word problems where we're translating. So they talk about here in this left column are important words. This doesn't cover all the words because English is such a live language. It's basically changing all the time. But important words like added to, sum of, added to means addition. Sum means the answer to an addition, which is going to indicate I need to do some addition, plus, more than, increase by, and so on. They're pulling out some key words that will indicate this operation of addition. Here's some sample phrases. So 700 pounds was added to the car's weight. So we would maybe rewrite that as W for the weight, and it's a pretty good idea when you use variable definitions, is try to use a letter that kind of makes sense for what the translation means. So W weight to the car represents the car's weight in pounds, and then we write the translation. This is the result we're looking for. These are kind of pieces to help us get to this point. So when they say 700 pounds was added to the car's weight, we want to translate that into W plus 700. Here's some examples with subtraction. One thing you really need to be careful with subtraction is the commutative property does not work, so you need to get these things in the right order. And this is probably where you have most of the errors, is less than, which indicates sometimes when we get the inequalities it'll indicate something too, but when we're talking about translating to algebraic expressions, that usually indicates subtraction. So it'd be very easy when we say this, we say 50 pounds less than the weight of the lumber. I see this mistake all the time that we define the variable W for the weight of the lumber and then write it as 50 minus W. That's not the same thing. If I did this, a lot of times it helps to just do a simpler problem. That's a good strategy to make sure that I'm effectively translating something. And if I replace the variable with a number, basically like I'm going to evaluate, I could put, well, what's 50 pounds less than 75? Would I write that as 50 minus 75 and get 25? No, I'd end up with a negative 25. So that's a pretty good indicator to say, hey, I got to make sure I get this in the right order, and so on. Multiplication, we have keywords. Difference, back to subtraction again. Difference is the answer to a subtraction. Sum is a word that we forget sometimes. Addition is the answer to an addition. And some other words there for subtraction. Multiplication is multiplied by. Product means the answer to a multiplication. And words we're going to run into, especially a lot of things around multiplication. One is a factor. That's parts of the multiplication. So they do the translations here, twice something or thrice something. I don't know if I've run into that very much. Or some words that indicate a number of times, right? So twice the wholesale cost would be 2 times the wholesale cost, or 2C. Of is something you got to be careful of, and in a sense I shouldn't say of there, but is sometimes that gets confused with division, because usually we're dealing with fractions at that point, which a lot of times we've gone through our math careers by avoiding fractions by treating them as translating them into division, which gets to be a real problem in algebra because of the properties. And again, the commutative property works with multiplication, so I could write any one of these expressions in a different order and I'd still be correct. But division, like subtraction, does not have the commutative property. So I have to write these divisions in the correct order or they'll be wrong. And quotient, again, is a big word, means answer to a division. Ratio means fraction, really. And ratios and fractions are really divisions of 2 integers, and we'll talk about what those number systems mean and so on. And per is a indicator of fraction too, or division. So they go through some examples here, just translating these things. Also, they point out here this less than thing right here that I talked about earlier, because this is a very common mistake. And you'll run into things in the book where it'll say caution, like this right here, where it says order in which we subtract and divide affects the answer. In other words, another way to say that, but they don't say it this way because we haven't covered the property, is the commutative property does not work for subtraction or division. Okay. And they got some more notes about language, good stuff to refer to, and then they translate these phrases into algebraic expressions. Again, that's probably not the end result of anything we'll do in algebra. Again, we're doing the pieces, basically putting the wheels on the car so we can drive the car. These are part of the wheels here, okay? But a lot of language, you need to know where a wheel goes on the car or what a wheel is, right? So know what expressions are and so on. Translating to equations. Now, this equation deal compared to an expression is we have an equal symbol, and which implies a lot of stuff, and there's a lot of different rules that we can deal with now that we get into equations. An equation is a number sentence with the verb equal to, okay? And that symbol means equal. So it's important to be able to distinguish between expressions and equations, and that's what they're saying here. Expression, no equal sign, compared to the English phrase like the interesting book may be of any length x, or this more complex one here. An equation has an equal sign, and to compare it to English, it'd be more like a sentence, where we have all the parts of the sentence, where this was or is like our equal sign. It may be of any length. Again, here's a couple examples. And then they go through the translation stuff. Words indicating equality or equal is the same as, equal, is, are, was, were, represents, are some of the words that are used to do that, not all of them. So when we're going to translate a problem to an equation, we first translate the phrases to algebraic expressions, and then the entire statement to an equation containing those expressions. So let's look at example 5. Translate the following problem to an equation. What number plus 478 is 1019? They're going to go through a lot of strategy stuff here right away. They don't indicate this, but this is always, whenever I have a word problem, this is a very simple one, but I want to make sure I understand what they're going through. And basically what I talk about is define your variable. And in this case, what is the variable here? What's the thing or the unknown thing that could vary right here? And it's the number that will be added to 478. And what will that equal when I take that number I don't know the value of, add 478, and then it says is, which is a good indicator of equal, and then this number 1019. So sometimes, though, really good to look at that. I say, well, let's let y represent that unknown number is. Then I'd say, what number is y? So I'd say y plus 478 is 1019. So I'll reread the original problem, substituting in this y, or this defined variable, could be any letter, and read it back into the original, and a lot of times it will write the expression for you, and in this case then follow it up with, well, is means equal, and then the numbers in there, and I end up with this equation. And then we'll talk about what we do with these equations, which is obviously the question is what number. So we're going to learn rules and how to solve equations so we can find out a solution or a value we can substitute in for y that makes this equality, this equation, equal and true, really. So both sides end up being the same value. Here's another translation. A little more complicated here when they get putting some other words in here. So we got the Sidu River Bridge in China is the world's highest bridge. At 1,550 feet, it is 270 feet higher than the Baluarte Bridge in Mexico. I'm sure I hacked that name up pretty bad. How high is this bridge in Mexico? Okay, and you can actually gives you a link to go look at thehighestbridges.com. Well, they define the variable right away. That's what I call it. Define your variable, which is they're going to say h for height of this bridge. In other words, what are we looking for? Usually we can define the variable to represent the answer to the equation, which is the height of this bridge. They call that h in feet. A rewording in the translation as follows. So I could go back in here and let's look at, just go back to the original. It says this bridge in China is the world's highest bridge. Okay, great. At 1,500 feet, it is 270 feet higher than h. That's, we replace this bridge name, the height of this bridge name, named here in Mexico, h. So let's read that again. 1,500 is 270 higher than h. And we end up with this expression, and because these two things are supposed to be equal, we have an equation. When we translate a problem into a mathematical language, we say we model the problem. A mathematical model is a mathematical representation of a real world situation. And also when we do that, we can take, these are really pretty relatively simple problems, but when we get into more complex problems, we can model it into algebra and basically use the rules that we will be introduced to and not do complicated things. I like to say is really just complex, meaning we're just going to take some, as they get to be a little farther from their solution, we just take more steps to get there. Another way they can give us an example or a word problem is say, here's some data, right? Here's information we know. This is, I put so many these numbers in here and I get these values out. And they want us to find an equation. So to write an equation for A in terms of n, which means A will be the one side of the equal sign and the expression involving n will be on the other side. So they start looking at what we have is a comparison or relationship between these numbers that we want to say, well, what would happen if I had a different number in here, like 20? What would be the amount charged? Well, I can write an expression just from this data to create an algebraic expression and then an equation. And that's what they start doing. They look for a pattern in the data, and they say since the amount charged increases by the numbers, as the number of song increases, we can try dividing the amount by the number of songs. So for $1.98 we got 2 songs or 99 cents a piece, and then so on here. At $2.97 for 3 it's 99 cents. Hey, there's definitely a pattern here. When I take the total amount of money divided by the number of songs, I get this 99 cents. So the quotient, the answer to these divisions, shown as fractions, which are divisions, we find out that it always ends up to be 0.99 or 99 hundredths. Thus each song costs 99 cents. We reword the translation as follows. The amount charged A equals 99 cents times the number of songs. So we didn't start with necessarily the phrasing and English phrasing. They gave us data and we had to basically say what's really going on here, and can I write a expression and then an equation to represent that. And there we are at the homework, and you can do your math lab practice. Again, your goal is when you get through all the problems in this homework that you have 100%, and good luck.